This lesson is on simplifying complex numbers with I. So a complex number is a number that has two parts. The first part is a real number, so a, in this case, an a plus bi is how we would write a complex number. The a value is a real number, and the bi value is an imaginary number, because I, of course, we know means that it's imaginary. So when we simplify these expressions, we are going to just simplify the negative radical negative 24 as we normally would. So the square root of negative 24 I would break into parts of negative 1, of positive 4, and positive 6. So I chose 4 and 6 rather than 8 and 3 because 4 is a perfect square and the square root is 2. The square root of negative 1 is I. The square root of 6 is a messy number, so we're just going to leave it there. So the 8 stays the same, a 2i comes out of my radical, and a 6 stays inside, and then of course I have a 6 in my denominator. When we simplify this, which will come into play when we get into the quadratic formula next week, we're going to simplify the stuff that's outside of the radical. So the 8, 2, and 6 can all be reduced by dividing each by 2, which gives me 4 minus I radical 6 over 3. Notice I did not simplify the 6 because it's inside the radical, and therefore I can't reduce it in the same way that I did the 8, 2, and 6. Here's one for you to try. So press pause, do this question, and then press play to check your work. So looking at the radical negative 27, I would break that into radical negative 1, radical 9, and radical 3. The square root of negative 1 is I, the square root of 9 is 3, and the square root of 3 is ugly, so it stays inside. So this is 6 minus 3i radical 3 over 3. Notice the 6, 3, and 3 can all be reduced. So the 6 reduces to 2, the 3 reduces to 1, so I'm not even going to write it. I keep the I radical 3 right where it is, and the 3 reduces to 1. But we all know that we don't have to write something as a fraction if the denominator is 1. And so my final answer is just 2 minus I radical 3.